We want to take a look at graphing a line that is in slope-intercept form. So in general, in order to graph a line, we need a minimum of 2 points so that we can connect them to make a line. So for slope-intercept form, that's our y equals mx plus b. So you can see that right here, y equals mx plus b. We're going to get these 2 points directly from this formula. So our first point is going to be the y-intercept, and we get part of the y-intercept here from this b value. So this is part of our y-intercept. So the b value always describes the y portion of the y-intercept. And if we remember the definition of the y-intercept, this is where the line crosses the x-axis. We've seen that a little bit before. And any point on the y-axis will have an x value of 0. So this is always going to look like 0, comma, whatever that b value is. So that's going to be our first point that we start with. The second point we're going to obtain by using our slope. So the coefficient of x here, that's always our slope. So we're going to use our slope to find that second point. And we can use that slope to find more than just a second point. We can use it to find a third and a fourth, but at a minimum, we need one more. So if I'm graphing this line here, y equals 3x minus 2, the first thing I want to do is find my y-intercept. That's my first point. So we always know that our x value for our y-intercept is going to be 0. And then we need this b value here, which is a negative 2. So that's going to be our very first point. And then we're going to need our slope. So slope is just the coefficient of x, which in this case is 3. And especially when we're graphing lines, it's very helpful to write our slope as a fraction, 3 over 1, and we'll see why in a moment. So we're going to go ahead and graph this guy. So I always start graphing by plotting my y-intercept, or whatever first point you're using. It actually won't always be a y-intercept, but for slope-intercept form, it will be. So 0, negative 2 is right here. That's our y-intercept, okay, our first point. And now we're going to use our slope. So slope we describe as rise over run. So this is an up or down movement divided by a right or left movement, right? So up and right are always going to be kind of thinking about positive, whereas down and left are always going to be referencing a negative value. So for my slope, currently I have a positive 3 over a positive 1 to make that positive slope. So I'm going to want to go up 3 and to the right 1, right? 2 positives. But we can also recall that, well, 2 positives give me a positive value, but so do 2 negatives. So if we think about this line, and we can sort of estimate where it's going to be here, right? It's about what our line is going to be. Instead of going up and right, positive, positive, I could have gone down and left, negative, negative, and that will also give me a positive slope. So down 3, left 1. And we can see that that point also fits nicely there on our line. So let's get a few more points. I'm going to continue from that second point that I graphed. So up 3, right 1, up 3, right 1. And now I've hit the edge of my graph, and I can connect my points to make a line. And you just want to make sure that because it's a line, it extends off forever in either direction, so you need arrows on there, right? So we have our y-intercept, then we had our slope, right? Up 3, right 1, or we could have done the opposite, down 3, left 1. You can think about it as positive and negatives, but they both got us points on the same line. So let's go ahead and graph a few more down here, okay? So first thing I'm going to do is kind of write my different pieces. So this one has a very similar slope, 0, negative 2. It's actually exactly the same. Or excuse me, a y-intercept, but it has a slope of 1/2, so that's a little bit different. But we're going to start the same way. Plot your y-intercept down there at negative 2 and use your slopes. This is a positive 1 over a positive 2, so I can go up 1, right 2, and I can do that to the edge of my graph, or I could do the exact opposite, down and left. And you can see that those points fall on the same line. So now we can go ahead and connect them. And there's our line. So we're going to do number 6 before number 5 real quick. So here our y-intercept is 0, 5. 5 is our b value. And our slope is -2, or we could say -2/1, because it's helpful to think about it as a fraction. So we're going to start plotting at our y-intercept, which is 0, 5. And now I have a -2 divided by a +1. So I want to go down, negative, right, positive, down 2, right 1, down 2, right 1. So down and right, down and right, down and right. Or I could do the exact opposite, right? All we need is one negative, one positive, so up and left works as well. And we can see that that lies nicely on that same line. So here is our line for that equation. Okay, so sometimes we get graphs or equations that look like number 5 here, where you'll notice the only variable we have is y. So what this tells me is that this equation is only giving me information about what the value of y needs to be. It's telling me nothing about x, which means that I am left to my own decision about what I want x to be. So all I'm going to do is pull off 2 points, right? Because we know we need 2 points to graph a line. All this equation is telling me is that the y value needs to be 3. It's not telling me anything about x, which means it's leaving it up to me to pick my x values. So I'm just going to pick some nice ones. Let's say -2 and 4. Right? I get to pick those because the equation didn't tell me anything about x. So all we need to do is plot 2 lines, 2 points to graph a line. 2 points to graph a line. So let's plot these. -2, 3, and 4, 3. Well, we have 2 points, so that means we can connect them to form our line. So what we can see is this is a horizontal line. So what we know about horizontal lines is the slope is 0. So all of our horizontal lines are going to have the form y equals some number. So that's always going to be a horizontal line. All right. And it's always going to be a horizontal line through whatever this value is on the y-axis. So this one was y equals 3, so it's a horizontal line through 3 on that y-axis. So those are some examples of graphing in slope-intercept form.